Everyone, this is Chaitanya. A very warm welcome to everyone attending the webinar. I'd request you put your questions in the chat box at the end of every section. I'll be taking up questions. So here's the agenda for this session. Everyone, this is Chaitanya. A very warm welcome to everyone attending the webinar. I'd request you put your questions in the chat box at the end of every section. I'll be taking up questions. So here's the agenda for this session. Just to set this agenda right, in this webinar, I would mostly speak on the everyone business aspect of data science. This is Chaitanya. A very warm welcome to everyone attending the webinar. I In the first section, I'll give you an overview of changes in the recent time the industry has gone through so that we'll get an idea of career opportunities the industry has to offer. A brief introduction. I'm an electronics engineer with 14 years of experience in the field of embedded systems, IoT, and data science. I have been conducting professional trainings and mentoring students for last 10 years. Before we start with the session, let's have a look at what data science exactly is. In God we trust, others bring data. This is the motto of almost every industry today. Earlier, the decisions were taken on certain judgment and experience, but today, mostly the decision making is data driven. The textbook definition of data science is an interdisciplinary field that uses scientific method, processes algorithms, and system to extract knowledge and insights from many structural and unstructured data. Here, the word structure, unstructured is very important. We'll see that later in this session. Every section that I've mentioned over here is an independent career path in itself. And uh, I'll just briefly touch upon each of these career paths which are there. So, first aspect is capture, in which you are acquiring the data from various sources, be it human or processes. Then, second aspect is processing this data, which basically is data mining and classification. Third part is analyzing this data, which is machine learning, deep learning, and analytics. And this particular section would be the main focus of our webinar today. The fourth section would be communicate. Here, it is mostly related to human consumption of data, which is data visualization, data storytelling, business intelligence, reports, etc. And all these activities are integrated with maintenance of data like data warehouse, data lakes, etc. So, what is the common link between them? You can put your responses in the chat window. So, basically, you might have guessed that these are all designs generated by artificial intelligence. Moda Rapido is a brand by Mintra, and the T-shirt that you see is being designed by an artificial intelligence engine. And right from the selection of fabric design and what would be the reception of this particular t-shirt in the market, everything is done by artificial intelligence. Next, what you see is an interior design which is generated by artificial intelligence. There is this company called Space Joy which offers interior designs at one tenth the cost of what a normal designer would charge. And the third picture, it is quite famous. It's a painting done by an artificial intelligence. And what they have done is they have combined a painting of a great artist along with eyes of various animals. And there is a parallel industry wherein such paintings are put up in art gallery, and people actually buy these paintings which are generated by artificial intelligence. So what is artificial intelligence? Artificial intelligence has two subsets, machine learning and deep learning. What machine learning does is it's an algorithms set of algorithms which extract patterns from data, whereas deep learning is slightly advanced. It extracts patterns on their own, so very little input has to be given by the user. So deep learning algorithms extract patterns on their own, but the output of machine learning essentially is prediction of a certain event. And machine learning is like an engine. So unless this engine is fitted to a car, it serves no purpose. And this is where artificial intelligence comes into picture. Artificial intelligence integrates this machine learning output in such a manner that it would act and adapt to the input coming from machine learning algorithms. So, just to simplify, I'll give you an example of driverless car. So, in a driverless car, there is cameras, a set of cameras and sensors, and these sensors are feeding information to a machine learning model. So, this particular data, which is coming from cameras and sensors, the machine learning algorithms are converting it into objects and the nature of object, like what type of object it is and how close or how far that particular object is it moving, static, those kind of information the machine is extracting. The artificial intelligence is taking this input from machine learning and it is using to steer the car, regulate its speed and follow traffic rules. So this is an generic idea of what artificial intelligence is. Now, what we'll do is we'll listen to what CEO of Honeywell has to say. Dave Cote is the CEO of Honeywell, and the reason I've taken this particular example is because this is very pragmatic in nature. What he mentions is something that I have experienced in my own career. So please listen to what he has to say.
Engineering disciplines are those 23,000 engineers in? You'd most likely say mechanical, electrical, and chemical. The fact is, of our 23,000 engineers, almost half are developing software. It's not mechanical, electrical, or chemical. So we have 23,000 engineers. Describe for me the composition. What engineering disciplines are those 23,000 engineers in? You'd most likely say mechanical, electrical, and chemical. The fact is, of our 23,000 engineers, almost half are developing software. It's not mechanical, electrical, or chemical. It's developing the software that's going to interact in those three disciplines. So for us, about 11,500 engineers are already developing software. That's going to become a bigger and bigger component of what we do, and it's going to transform the century. The reason it's going to transform the century is you may be impressed with computing power today, but if you assume power continues to double every 2 years the way it has in the past, some people would say it won't. I don't agree with them. They've been saying that sort of thing for 20 years and it keeps finding a way. So let's assume it doubles every 2 years. 10 years from now, we will have 32 times the computing power we do today. In 20 years, we will have over 1,000 times the computing power we do today. And you start to think about what that could enable, and quite honestly, none of us can even envision where it's going to go. If you have over 1,000 times the computing power we do today, 20 years from now, it's tough to imagine all the things that are possible. But they are coming, and it's going to have a big impact on companies like Honeywell and the entire. You think about being in a refinery. There used to be all kinds of edge devices. There still are. I mean, there's all kinds of edge devices sensing things all the way around. Well, what used to have to happen is somebody would kind of go out and record whatever they had learned. You start to get to a point of meters, and now the guy can walk by with a meter and kind of pick it up as he walks along. Well, because there's a little piece of software in there, you can make it a little more powerful as computing power exists, connectivity improves, and now you can actually have the signal sent from that device to the center. And you don't even need that guy to walk around anymore. So some machine in the center and say, okay, here's what needs to be done. With a few more advances of computing power, that person doesn't even need to look at it anymore. The data is automatically accumulated. The machine is analyzing it, determining where there might be a problem, where there might not, or what changes can do it automatically. You're going to see more and more of that everywhere, whether it's how you control buildings, how you control factories, aircraft, everything is going to be affected by it. Right.
Okay, so I had worked on a similar project, which was automation of oil depot, and there I could see people walking around with walkie-talkies and taking measurements from different sensors and relaying it to people sitting in control room, who would then take necessary action. Basically, the data was generated by people earlier, and now it's being created by sensors. This data is significantly accurate and very unstructured in nature. Most of these engineers employed by Honeywell are trying to solve this problem. For those who are not aware of what Honeywell is, it's a automation based company. So for example, there is a chemical plant and it has to be automated. Honeywell would come and they would feed a lot of sensors and valves and other things into the plant and take that information to a control room where people can monitor what is happening and control certain actions. So essentially, Honeywell is a traditional electromechanical based companies, but today they are employing close to 50% of people who are software engineers. Now, there are three very important things that he has mentioned. The first is that the number of people who are developing software is almost equal to all the other engineering disciplines, and that is coming from a traditional company. Honeywell is not an IT company. Second thing that he has mentioned is the data that is being collected from the sensors. With IoT, that data is fed to a centralized repository, and then that particular data is mined by those repositories to extract information from it. Now, the third and the most important thing that he has mentioned was rise in computational power. Machine learning is not something that has been invented today. And if you have to trace, you'd find that these algorithms were invented at least 100 years ago. Neural networks was first discovered in 1950s, and the first commercial implementation was done in 80s. But the only reason that we have seen spectacular growth today is because we have the computational powers to run these algorithms at scale, and it is delivered at a cost which is commercially feasible. In a nutshell, this is how data has evolved. So, just to describe this, I can take an example of car. Now, you might be familiar that every car has this particular device called OBD port. So OBD port is basically a black box which is connected to a host of sensors in your car, and it is collecting all the information from your vehicle. So that is description. Every entry level car today, even like Alto, has that kind of a device. So what happens is, if at all there is some failure in your car, and you take to a mechanic and he's not able to figure out visually what has gone wrong, so what he would do is he would connect that OBD port to a laptop, and from that software he would try to diagnose what problem is there in the car. Now, till this point, every car manufacturing company is doing. Now, what Volvo has done is they have connected this OBD port to internet, so IoT, and this OBD port is basically transmitting all the data to internet, and their engineers are mining all this data to predict any failure which will happen in near future. And what they'll do is they'll give you a notification saying that, hey, your car has this kind of issue, and we anticipate in next 1 month you would face a failure in this particular component. And they would give a soft push to a customer to go to their authorized service center and purchase genuine parts. Now this is very important, very very useful customer service, because I would not want to end up in middle of an highway and take whatever the mechanic is offering to me. And this way the business of Volvo is also growing. Now, the fourth step is prescription. So what they are doing is, further they're taking this data and they are relaying it to service center and informing them that this particular car would arrive with this particular problem, and this is the solution for this problem. What you will have to do is make sure these components are available, and when the car actually comes for servicing, all the mechanic has to do is follow the steps he's been given, and the car would be delivered to the customer in no time. So this service has two very very important aspects from perspective of Volvo. The customer, if at all he's getting this kind of a service, he would always go to an authorized service center. So Volvo is getting more business, and at the same time, Volvo is also giving a kind of experience which would bond the customer, and they would be able to push more services to him. Today, any manufacturing company, specifically, you can say car, automobile industry, they are having margins which are closer to 1%. And every month in India, at least 10 major models are launched by car companies. So you can imagine what kind of competition is there in the market, and what more the car companies, or for that matter every manufacturing company, has to do to differentiate them from the competitor. And they can only do it with the knowledge of data. So here I'll wait for your questions. I cannot see any questions. Probably there is some issue with my YouTube. So I guess there are no questions. Now we'll see what is the growth driver for jobs in industry. So in 1990s, those who are of my age would remember that with advent of internet and Y2K problem, anyone who could spell Java, Java, would get a job in IT industry, and they would train him in whatever technology they would want and send him to US. This happened because there was a sudden surge. All the banking and financial institutes wanted to take their operations online, and there was this sudden growth. And as it happens with every industry over a decade, when this problem of automating the banking and financial operations, this issue was resolved, the growth trajectory sort of became flat. What I mean to say is that the jobs did not dry up, but the thing is that the industry was not generating new jobs the way it was generating in the early 90s. Now, the next phase of growth came, which was the smartphones and social media. So, with smartphones and social media, it offered something, a common user, internet on the go. So wherever the person was, he could consume internet, and this opened up a new channel for advertising and taking products of the company to the user as well as entertainment. And again, this channelized a huge growth. So now in 2015, two very important technologies evolved. First was the devices. The devices were now, it was now feasible to connect the devices with internet, and their cost has significantly reduced so that you could connect hundreds of devices to your system to collect this information. And second thing was the cloud computing, the scale at which cloud computing could be taken and the cost at which it was offered has come down significantly. So it was kind of a dream combination, and this gave a rise to a big demand in data science. Earlier, the decisions made by a company had to be taken based on personal experience because data was not available. Now, because the data is available, the companies not only take decisions to build their products and services, they are integrating this in every aspect of their business process and product. And this has seamlessly entered in your life. So this is a report which is published by Gartner. Gartner is a top consultancy company, and they would mostly interview CEOs and CTOs of top Fortune 500 companies on what their strategies would be, and they create reports which they sell. So in 2018, they asked top industry leaders what is their current status of artificial intelligence deployment and what they would do in next 12 months. So 23% of the respondents said that they would implement artificial intelligence in 2030, and 14% had already implemented that. Now, in 2019, when they did this survey again, what they found is that only 5% who had earlier planned in 2018 had implemented artificial intelligence. Rest of the 19% were still in process of implementation. And this has happened because they do not have sufficient number of data science professionals. Now, this is one of the major reasons. Apart from that, there are a lot of other reasons like availability of data. Then there are legal issues related to acquisition and consumption of data, privacy, security. Okay, so there are such other issues as well, but the major issue being is the availability of data science professionals. So now we had come to the roadmap of getting a career in data science. So, timing, I'll just pause for a few seconds to get any questions. Please post your questions on the chat box. Okay, so first question is there are a lot of questions coming in. Okay, so can data science really helpful for civil engineers? So, yes, I'd be talking that in the slides, but data science is not a career which is very, very specific to computer science engineers. Data science is more about domain knowledge. What skill and interest areas are required to become take a career in data science? So basically, I'll talk about the skills in coming slides. What is the basic criteria of the course? So all this I'll be digging up this in subsequent slides. So let's start with it. So this is the hype curve which Gartner had given in 2014, and you can see a lot of technologies which are there. So this particular video we would be sharing, and you can have a look at this particular image later on in detail. So what you see over here is if you start from the left hand side, so you can see a very steep curve which is rising, and you can see all these kind of technologies: autonomous vehicles, speech translation, internet of things, wearable devices, etc. So this rise is basically a hype for that particular technology. So the industry starts anticipating something very, very unrealistic in this particular phase, and then there is a peak where the expectations are at the peak. Then what happens is, over a period of time, that these expectations are not met by the technology. After all, there is something pragmatic, rather what I would say is that every technology which is there, it takes time to mature. And for commercial implementation of any technology, it's a very, very big challenge, and especially with every passing day, that challenge becomes bigger and bigger. So what happens is, you'd see that there is a steep fall in the hype of these technologies. So what has happened in the second phase is that because the technology has not met the expectation, the interest level of people have come down, and then it would again reach what you would say the bottom part. And from that point, because over this period of time the technology has matured, it starts delivering results. And you can see this timeline which was given in 2014. Okay, so what they have said is after 2 to 5 years, a plateau would be reached, which you can actually experience. Okay, so just to give you an example, you can see at the peak variable wearable devices are there. Okay, so there's Google glasses and a lot of hype in last 3 4 years, but it couldn't deliver the kind of expectations people were expecting from that technology, and that product simply died down. But what happened is that these industries like 3D printing, okay, now 3D printing is very, very extensively used in industry for designing prototypes of products, speech recognition. Okay, so these technologies have started maturing to a level where commercial implementation is possible. And what you can see is right now in 2020 we are in the slope of enlightenment. Now, here is the hierarchy of careers in data science. So, with recent changes in the industry that I had spoken earlier, it has created two new roles. So, I've just listed the hierarchy, and typically there would be different roles in different industry, and it's not possible to map all these, but within the scope of our discussion, these roles are very important. So the two new roles that have been created are data science manager and product manager. So otherwise, CTO, CEO, machine learning engineer, data scientist, and all that, these roles were there in industry even when data science, or rather, you hadn't heard of artificial intelligence. So, what a product manager does is basically designs new products for a company. So let me just let's try to understand with an example. Like Flipkart, it has an option of lazy pay payment. What lazy pay is basically a 1 month credit. You can just go on buying products from Flipkart and it would be credited to your lazy pay account, and at the end of a month, whatever that total amount is, you have to pay. So now a product manager, what she would have to do is she would have to analyze what all steps have to be taken. Now banks and financial institutes are there, so she'd have to interact with them, what kind of credit they would provide. Then she would have to understand who are the customers whom this offer can be given, how to assess the credit worthiness, what is the risk in giving such option, and such other things. So what would happen typically is that product manager would require a lot of data and information how this can be implemented, and she would refer to the CTO that I want all this information. So with the growing nature of requirement of data, this new role of data science manager has been created to offload that responsibility from the CTO. So a data science manager is basically a person who is having good managerial experience as well as good knowledge of data science. So this particular person would assemble a team of analysts, data scientists, and machine learning engineers. Now let's understand role of each of these members. So business intelligence manager, he is a domain expert. So in our case, he would have expertise in financial domain. He would understand how banks work, what kind of data they need, what kind of data has to be given to them, how to measure credit worthiness of a person, how to calculate risk for a given particular product. So all this knowledge he has, and what he does is he puts this knowledge into an Excel sheet or whatever tool he is using, probably an SQL database, whatever they are using. He puts all this information into that. He takes data from his own company database. He'll ask for some data from the bank and try to analyze what has to be done. And what he would do is, along with data scientists, they would try to analyze what can be done out of this data. Now, once this analysis part is over, the data scientist, who is an expert in field of data science, who's typically masters or PhD, typically PhD in data science, they would take this data and build a learning model which will extract all this information from the data that is available. Now, as I had mentioned earlier, the learning model is like an engine, and that engine has to be fitted into a car, only then it would serve its purpose. So, what happens is, machine learning engineer, he would take this data model, which is usually programmed in R or Python or any such language, but his cloud computing solution is probably running on Java. So he has to first convert this code into Java. He has to integrate it with his own database, probably, and what all banks are there. So he'll have to integrate that solution with the banks and deploy it at a scale where a few million users can access it simultaneously. So that is the role of machine learning engineer. So this particular role is a core engineering role. So, uh, this is the data science in action. This particular pyramid basically lists all the functionalities in this particular cycle. The first cycle is collection of data, and this is the most important cycle. Failure or success of your learning model typically depend the person who is working in this particular domain has to have really good expertise in that particular domain, and so that he'd be able to collect right information from this data. Just to give you an example, this is something somewhere around in 2016-17. There was this company in Pune, automobile company in Pune, and they decided that they would want to build their data science team. So what they did is they hired a few data science professionals, gave them all their data, and said that, do something for us with this data, give us some information. So they worked on it for 3 to 6 months, and whatever information they were giving to the top management, they were not happy with it. And slowly they were losing confidence in this entire concept of data science. So what the top management did is they asked a senior manager in their company that, we are doing this particular activity, and this data science team is struggling with this data science model. They are not giving us relevant information. So can you just go and check out what they are doing and probably help them to get started? So when this manager, he met the data science team, he took the stock of the situation, then they brainstormed a few ideas, and after a few months of efforts, they were able to derive a learning model which basically gave average life of individual components. So what this automobile company did is, they earlier, this particular vehicle had one comprehensive warranty, like 2 years warranty on everything, okay, right from engine to the chassis and everything. So what they did is they took the major components like engine, the silencer, the chassis, and other these, they separated these components in various buckets and gave different warranty periods for each of these components. So what effectively happened is that the customer got higher warranty than he would have normally got with their earlier 2 years warranty, and at the same time it reduced the liability of warranty damages for this automobile company. So now all this exercise could not have happened had this senior manager not come into picture. Had he, so this particular senior manager, although he did not have the knowledge of data science, but he was able to build a good data science product with his domain knowledge. So basically, data science is not restricted to a specific, uh, class of profession. So across the profession, you can pursue career in data science. So each of the pieces that you see in the pyramid, these are individual career paths in itself. So whenever you decide that, okay, fine, I would want to switch my career to data science, so you would have to first reflect yourself, like what are your strengths, weaknesses, and in this particular pyramid, where do you fit in, where does your role fit in. Now next is a storage, retrieval, and rule based access. So basically, with the advent of cloud computing, the complexity of maintaining the storage infrastructure has been completely isolated. Okay, so that uh, those jobs are completely gone. But what has happened is, because of the kind of demand that is coming, okay, so this access has to be completely role based, secure. There are a lot of government policies and all that. So this has created a new segment for storage, retrieval, and rule based access of data. Then next is preparation of data, that is organize and clean the data. So the data that you are getting from any source, probably it is in form of pictures, videos, or it is coming from sensors. So this particular data is not suitable for machine learning model. Okay, that data cannot be fed as is to the machine learning model, and there is a lot of pre-processing that has to be done for the data. And a person who has good knowledge of that particular domain, only that person would be able to do so. This role basically is very domain specific, as well as this particular role demands that you have good understanding of data science. Now the next two roles which are there, analysis, prototyping, and testing. So these roles are for data scientist and analytics, so they are intersecting at some point. But person, let's say, who's working on SQL database, let's say he's working for a large retail chain, okay, and they are using SQL database, and you are doing business analytics and reports generations and all that thing. So this is the role which is suitable for you, analysis. Whereas data scientists, once all this information is available, then the role of data scientist comes into picture. Data scientists would take all this information and build a learning model which is up to the expectation of the business requirement that is there. And ultimately, this learning model is taken by the machine learning team, and they would put this model into production. So here, core engineering skills, that is of computer science specifically, you need to have core engineering skills. That is, you should be expert in Hadoop, Java, big data, all these kind of technologies to get this particular role. Now what skills are required? So is programming skill important? No. So, I had mentioned the bottom two layers, that is collection of data and preparing data. So, in that case, you do not require programming skills. But learning Python would be of great advantage because it would take a few days or at the most month to learn Python. Python is not that difficult language to learn. But if you are learning Python, that is an asset for lifetime. You would not have to learn any other language, and that would serve you very well in your career. Now, the next question is, can freshers also get a job? Yes, definitely. Freshers can get a job in this particular segment. But it is not as straightforward as any other domain. So for example, if you're looking for a job in Java or C++ domain, so you might do a certification course and you would apply to companies, and in most likely case, companies might offer you a job if your skills are good enough. But in case of data science, only a course is not enough. We'll talk about that in the subsequent slide. Now, the last question is good understanding of maths, basically calculus and statistics that you had studied in your high school or probably in your engineering. So, is this important? Yes, this is very important. And sanitization criteria. That means if at all you have to take up any career path in data science, then it is imperative that you have good understanding of maths. So, I hope you might be having a lot of questions. I can see few questions coming up. Okay, so these questions are related to criteria and what kind of skills are required. So basically, I've covered that. Now, this is the last section. We are at the end of our presentation. How to kickstart your career. Now, basically, there are roughly 10,000 courses on Udemy offering different types of courses on data science. If you go to Coursera, Stanford University is offering you a certificate course in data science. So basically, if you do any of these courses and go to a company and say that, I have a certificate from Stanford University, the company would say that, okay, fine, you have a certificate, good. Let's keep it side. Let's keep it aside for few moments. Now, you first tell me what you have done in data science. So, having a certificate alone is not important because today the companies, they are not looking into your academic qualifications specifically for data science. What they would want to see is what have you done in past in data science. Now, it's a classic chicken and egg problem that since you don't have any experience in data science, so you cannot get a job, and since you don't have a job, you won't be getting experience. So how to crack this? So these are the four steps to crack your career in data science, and there can be n number of other ways as well. But what I can assure you is that if you're following these four steps, you would have a very clear roadmap in front of you, and this is the least risky way of pursuing the career. So, step one is practicing on real world data. Okay, so probably you might have done course, probably online or classroom course, or you might have studied data science on your own. But unless you practice it on real world data, it has no real value because data science as a career is not about programming. It is more about the data, how you are handling the data. Over a period of, as I'd mentioned, these algorithms have been there around for probably 100 years. So, over this period, these algorithms have matured to an extent that they are very reliable. And these algorithms are programmed into various programming languages wherein you can implement a basic learning model in just 2 3 lines of code. So programming is not the key. The key is data, how you work with data. Now the second step is you have to interact with business community. The reason being is new job roles are being created by the industry. So in previous slide I had mentioned about data science manager, product manager. So these roles are very senior roles, but the thing is that probably you might reach that position in 10 years, but the preparation has to be done today. So it's a step by step process. You have to first understand the domain. You have to understand what is the career path in that particular domain, and you have to reflect within yourself. Do you have natural skills in that domain, or you have inclination towards that domain? So this can happen only through interaction with business community. Okay, you cannot sit at home and check out few forums, what's going on and all. Okay, so unless you interact with a experienced industry professional who typically has 5 to 10 years of experience, you would not understand what career path you have to take. Then third thing is solve real world problems. So probably you're looking for job, so you shouldn't be sitting idle. What you should be doing is that real world data you have, you can extract this data from anywhere. There are a lot of social media posts that are there. Then a lot of sensors which are there, and there are a lot of free APIs that has been provided. For example, the stock market which is there, so they provide free APIs for you to extract data from the stock market, and you can work on that data. So try to solve some real world problem. It might be very very trivial in nature, it doesn't matter, but what matters is that you should be able to do it on your own. That should be your own solution. And the fourth step is, this is the most prominent step, is to participate in competitions. So there are a lot of hackathons which go around, or a lot of companies. What they do is, in order to solve a certain data science problem, they are not hiring professionals. They are announcing online competitions. They are putting all the data and asking people to solve this particular problem. And you should participate in this particular competitions, because it's the aim is not winning the competition, but when you get into the competition you get real life data which is there. You get a drift of what is happening in the industry. And when you are participating in this competition, you are also interacting with the community. And what knowledge that you get from community is very very priceless. Here's a very very good example of that. This is Nina Mufle. So she's a girl from Arab, and she wanted to get job in Airbnb. And at that point, this was somewhere around in 2014 or 15. So at that point, Airbnb was not having offices in Gulf region. So what she did is she compiled this particular blog. And I've just put a small snippet of this blog. It's there on the internet. You can just check Nina Mufle blog, and you'll get the entire blog. So what she did is she did some research on what Airbnb is doing in Gulf region. What was impressed is the insights that data revealed to him, which was not given by his data science team. So he was impressed with that knowledge, and he interviewed her, and she got a job in Airbnb. So it's not like you would write a blog tomorrow and you would get a job in dream company. uh, this is something one in a million type of event. Okay, certainly probably you can say she has hit jackpot. But what I want to say is that this practice is being followed by a lot of people to get a job in data science. Finally, I'll just briefly close on to this slide. We are Avanta Technologies IT training service company. And what we do is we offer courses in data science. And now, as I'd mentioned, there are a lot of courses. So, how we are different? Okay, so the first thing is we are highly focused on learning. The courses that you have, it's like an open book, anyone can read it. But learning is significantly different from reading or attending a course. And what we have done is we have integrated live training sessions with lab exercises and evaluation test in such a way that you would learn something out of this. Along with that, we'd be having some projects. And if at all you want to pursue a career in data science, we would first have a good interaction with you, try to understand what are your skills and weaknesses, and based on that, we would offer you a roadmap. And we also have good industry connects because we all are experienced professionals from industry. So through our connects, we'd be able to assist you in finding jobs. So it is not like since we have good industry connects, we would, speak with our friends. Hey, this person is good. Can you offer him a job? So it's not going to happen in that way. But through our interaction, we would be able to fine tune what their requirement is and how you would be able to prepare for those kind of interviews. And most importantly, we'd get you a series of interviews so that the probability of you getting a job increases. So that's all, folks. If you have any questions, please feel free to ask. If at all your questions go unanswered, what you can do is you can send us an email on this particular ID, or you can also call on these two numbers, and one of our consultants would get in touch with you and resolve your queries. Suggest. So there is a question from Anjali Tavare. She is asking, suggest top universities for masters in data science and abroad. Basically, I would say Stanford is the top university as far as data science is concerned. And if at all you would like to know more about careers in data science, we can take this question offline. Okay, course duration and fees. So basically, the courses that we are offering, so they are from different domains. So I had mentioned in the slide earlier that there are different career paths, and based on your experience or the kind of career path you are interested in, the courses would be different. So what we do is we would get in touch with you offline and have an interaction with you regarding the course structure and the fees. So I guess there are no more questions, and we can end this session. Thanks everyone for joining this session. Thank you.